Hello, welcome to ENEC 13016 Concrete Technology and Design. I am Dr. Sarkar Noor-E-Khuda, the lecturer of the course. In this video tutorial, I will be discussing the topic moisture in aggregate, which is in line with concrete mix design. We will look at the different states of aggregate in terms of possessed or absorbed moisture. We will start with the oven dry OD state shown in the very left figure, where all moisture is removed from the pores of the aggregate particle. This state can be achieved in a laboratory environment by placing the aggregate sample in an oven at 105 degrees Celsius over a duration of 24 hours. The next state is the air dry state. You may refer it as the natural state, where there is no moisture on the surface of the aggregate particle, and the internal pores of the aggregate particle are partially filled. It is shown on the second figure from the left side. The saturated surface dry, in short SSD state, is the ideal situation where all the internal pores of the aggregate particle is completely filled with water. However, there is no moisture on the surface of the particle. The wet state, shown at the very right figure, is similar to the SSD state. The internal pores of the aggregate particle is filled with water. In addition, there is excess water on the surface of the particle. Now let's look into the interesting part of this topic. The amount of water required to fill the pores in the aggregate particle is referred to as its absorption capacity. From the above figure, we can define absorption capacity as the amount of water required to reach the saturated surface dry state from the oven dry state. In the previous slide, we mentioned that the pores within the aggregate particle are partially filled in an air dry state. The amount of water required to reach the saturated surface dry state from the air dry state is called effective absorption. At this point, let us do a little brainstorming. Look into the figure and let's understand which value will be larger between absorption capacity and effective absorption. It will be absorption capacity. We will now focus on the right side of the SSD state, that is the wet state. The basic difference between the SSD state and the wet state is that aggregate particle has additional water in wet state in the form of surface water or surface moisture. The general term moisture content of aggregate is determined from the simple formula shown here as the ratio of mass of moisture to the mass of oven dry aggregate. It is expressed in percentage. The wet mass M1 shown in the formula may refer to any of the four states. Now we will briefly look into the significance of state of moisture content of aggregate in regards to fresh concrete. If we are using an aggregate sample having moisture content less than its absorption capacity, that aggregate will absorb moisture from the concrete mix and reach the SSD state. Here I am referring to aggregates shown at the left side of the SSD state. If these aggregates are used in concrete, it will demand appropriate adjustment of water by increasing the water content of the concrete mix. On the other hand, if we use wet aggregate, it will release the excess water in the mix, thus increasing the water cement ratio of concrete. Here I am referring to aggregate shown right side of the SSD state. If these aggregates are used in concrete, it will demand appropriate adjustment of water by reducing the water content of the concrete mix. If moisture content of aggregate is less than the moisture content at the SSD state, then aggregate will absorb water. On the contrary, if moisture content of aggregate is more than the moisture content at the SSD state, then the aggregate will release water. Now we will briefly discuss the measurement of absorption capacity of aggregate as per the Australian standard AS 2758.1 and AS 1161.1. We have to follow the simple steps. First, Measure the mass of aggregate sample that has been soaked in water for 24 hours and from which all free surface water has been removed. Surface of the sample can be damp, but make sure it is not wet. The measured mass is MSSD. Then we will measure OD mass, MOD, of the aggregate sample that has been oven dried for 24 hours at 105 degrees Celsius in the laboratory. Now we will use the simple formula shown to measure the absorption capacity of the aggregate sample. If you carefully look into the formula, you may notice that absorption capacity is actually the moisture content at SSD state. The references used in this tutorial is shown at the bottom of the slide. I strongly encourage students to go through the Cement Concrete Aggregate Australia website, especially the technical notes. You may also refer to the book Properties of Concrete by Neville. At this point, we will solve an example problem to enhance your understanding to the content. Mass of a coarse aggregate sample at different states of moisture is given in the problem. Mass at natural condition, M1, is 2315.8 gram. Mass at SSD condition, MSSD, is 2301 gram. Mass at oven dry condition, MOD, is 2278.2 gram. Let's determine the absorption capacity and moisture content of the sample at natural condition. A note is provided at the bottom of the slide which details the mass measuring procedure. First, let us note the mass of the sample at the three different states, M1, MSSD, and MOD. Now we will calculate the absorption capacity of the sample. Let us start this with the absorption capacity equation. The required variables MSSD and MOD are given, which are 2301 gram and 2278.2 gram respectively. Using these values, we get the absorption capacity of the aggregate as 1%. Similarly, we measure the moisture content of the aggregate in the natural state using the moisture content formula. Use the value of M1 and MOD. Moisture content of the supplied aggregate sample is 1.65%. Let us now analyze the outcomes. As moisture content of the supplied aggregate is higher than the absorption capacity, the coarse aggregate sample was in wet state. The surface moisture of the aggregate will add to the concrete mix as free water. The amount of free water from the sample will be the mass in excess of MSSD, which is 14.8 gram. This ends the problem here. On slide 7, a practice exercise is given. The problem provides moisture content of a sand sample, its mass at SSD and OD state. You are required to find whether the sand sample will A. absorb or B. give moisture if used in concrete mix. I created a Go Soapbox quiz on this problem. The detailed information is provided at the bottom of the slide. I encourage everyone to partake in this quiz and choose between option A or option B. This ends the tutorial. Thank you.